Hello friends. So today we'll discuss the relative velocity profile assumption. So here there is a one shaft and the shaft have the radius r and the angular velocity that is omega. So the velocity, the linear velocity here, this is a v, okay, and there is a one journal bearing. The shaft is kept in the journal bearing, so the distance from the bearing wall to the shaft, that is h, okay. So if we see the large view here, so this is the solid surface and this is our shaft which is rotating, and here there is a velocity profile, maybe like this, and this is y direction at the distance between this and the shaft distance, that is h. Now consider u that is equal to a plus by. Now there are two boundary conditions. So boundary condition 1, that is when y equal to 0, then u equal to 0. So u equal to 0. So y equal to 0. So if we apply this boundary condition in equation 1, so 0 that is equal to a plus 0. So from here you can see that the value of a that is equal to 0. Now there are second boundary condition. So at y equal to h, the u that is will be equal to v. So at y equal to h, so here when the value of y equal to h, the u velocity will be v velocity. So this is written here. So y equal to h, u that is equal to v. So if you apply this boundary condition in that equation, so here v that is equal to, so v that is equal to 0 plus by. So from here b equal to v by h. Okay. Now if we apply these two value a and b in equation 1, so the equation 1 is u equal to a plus b into y. So u that is equal to 0, the value of a that is 0, plus the value of b that is v by h. So v by h into y. So from here u equal to v by h into y. So we know that tau that is equal to mu into du by dy. So from here tau that is equal to mu into dy by dy, that means that is the derivative with respect to y, that is v by h. So here v by h. So we see that, so tau that is equal to mu into v by h. So here v is also constant, h is constant, and mu is also constant. So tau is constant. So this is the important formula you have to remember. Tau that is equal to constant, that is equal to mu into v by h into v by h. Okay. So here we can say that is tau not equal to the function of y. So this is very important concept. So now we will discuss one problem with the depends on this formula. Okay. So the problem will be like this: a 90 Newton rectangular solid block slides down a 30-degree inclined plane. So there are inclined plane, and this is the solid shaft, solid block which slides down on the inclined plane. Okay, and the weight that is 90. So given that is weight that is equal to 90 Newton and theta that is equal to 30 degree. Okay, now the plane is lubricated by a 3 mm thick film of oil of relative density 0.9. So here in between this and this, in between there is a lubricating oil. So lubricating oil, that this thickness that is h, and h is 3 mm, that is equal to 0.003 meter, and the viscosity is also given of the lubricating oil, that is 8 poios. This is the CGS unit. So we have to convert it in SI unit. So 8 into 0.1 poios means 0.1 Newton second per meter square. So from here you can say that mu that is equal to 0.8 Newton second per meter square. And if the contact area is 0.3, so here the contact area between lubricating oil and the surface which is also given, that is A equal to 0.3 meter square. You have to calculate the terminal velocity of the block. So you have to calculate the terminal velocity V, terminal velocity, that is constant, V equal to constant. So you have to calculate what is the value of V of this shaft. So V is equal to what? So if we apply the Newton's equation in that direction, so in the inclined direction, so you know that summation of F net, that is equal to M into A. So here there is terminal velocity V is equal to constant, that means there is acceleration that is equal to 0. So summation of F net, that is equal to 0. So here this is W is downward direction. So one component will be W sin theta and another component, this is W cos theta. But W sin theta is helping to downwards the solid surface. So this is the case. So W sin theta minus, there is a opposite force is acting on the solid block, that is FV, that is equal to 0. So here W sin theta minus, so FV, that is equal to tau into area. Tau is the shear stress into area, means this area, okay, that is equal to 0. So now W sin theta minus, what is the value of tau? So in here we calculate the tau, that is equal to mu into V by H. So here that is mu into V by H into A. Okay. Now so from here mu V by H into A, that is equal to W sin theta. So from here V, that is equal to WH sin theta divided by mu into area. So if you put the value, that is W, what is the value of W? That is 90 Newton into H, what is the value of H? That is 0.003 into sine 30 degree divided by mu. What is the value of mu? That is 0.8 into area, that is 0.3. So from here you can get the value, that is 0.5625 meter per second. So this will be our terminal velocity. So this is the answer. Okay, so this is the answer. Okay, now there are another question, second question, that is also very important question. So here the fluids of viscosity, there are two types of viscosity fluids are there. Viscosity of fluid 1, that is 0.1 Newton second per meter square, and viscosity of fluid 2, that is 0.15 Newton second per meter square, contained between the two plates. Each plate is 1 meter square in area. Okay, so here this is one plate and this is another plate. Okay, and there is a two fluid. So here there are two fluid. So this is fluid 1 and the distance from this is H1, and here the distance from here to here, this is H2, and this is VI. VI is the interface velocity. Okay, and here this plate is moving. So here this plate is moving, have a force F and velocity V, and the given case is that here mu1, that is equal to 0.1 Newton second per meter square, and mu2, that is equal to 0.15 Newton second per meter square. and the area is 1 meter square. Okay, so the thickness are h1 that is equal to 0.5 mm and h2 that is equal to 0.3 mm. So here the h1 is given h1 that is 0.5 mm and h2 0.3 mm. Okay, the upper plate moves at a speed of 1 meter per second. So this upper plate, so here the upper plate, this is the plate here, the upper plate moves a velocity 1 meter per second. Okay, so v that is equal to 1 meter per second. So what is the fluid velocity at the interface between the two fluid? So if you have to find out, there is a fluid 1, this is fluid 2, so you have to calculate the interface velocity in between the two fluid. Okay, so now calculate this. So here at interface, so we can write at interface tau 1 that is equal to tau 2. So tau 1 will be mu 1 vi, v is the interface velocity upon h1. So here in that problem this plate is fixed, so here this plate is fixed and this plate is moving, so relative velocity vi minus 0 that is vi. Okay, so this is why mu 1 vi by h1 that is equal to mu 2, what is the relative velocity, that is v minus vi by h2. So here in that case, so here the velocity v and this is vi, so what is the relative velocity, v minus vi. Okay, so v minus vi by h2. So from here there is mu 1 that is 0.1 into vi upon hi that is 0.5, that is to mu 2 0.15 into this is v is equal to 1 minus vi by h2 is 0.3. so from here vi will be 5 by 7 meter per second, that will be equal to 0.714 meter per second. So this will be our answer. So the interface velocity will be 0.714 meter per second. Okay, so this is very important concept and important question here. Now we'll discuss the topic that is very important. So consider there is a shaft here, there is a shaft, this is the shaft here, this is a shaft here and the angular velocity of this shaft that is omega, and in this shaft in between the bearing. So okay, now this distance is known as clearance. So here to here the distance is known as clearance. Okay, so consider this is point A, this is point B, and this is point C. Okay, and this here to here, so this point to this point, the distance that is L, this is small l. Okay, and the shaft radius that is smaller, consider this is smaller, and here to here the distance, here to here the distance is capital R. Okay, so clearance, how to calculate the clearance? H is equal to R minus R. Okay, so from here you can write VA, that is equal to VB, that is equal to VC. So point A velocity, that is equal to point B velocity, that is equal to point C velocity, that is equal to R into omega. So now if you want to calculate the shear stress tau, that is to mu into V by H. So what is the value of V? That is equal to mu R into omega by H. Okay, now this is the case. Now if tau is given, so how to calculate the F? That is equal to tau into area. And what is the area? What will be the area? Tau into, what will be the area? 2 pi R L. Okay, this will be the area, peripheral area of the shaft. This is the shaft here. Okay, and if you want to find out the torque, that is F of F into small r. Okay, this will be our torque. Okay, so so here, so our so TF, that is equal to FF into R. What is the value of FF? That is tau into 2 pi R L into R. Okay, so tau, that is equal to mu R omega. So from mu R omega by H into 2 pi R L into R. So from here you can calculate the TF, the torque, that is 2 pi mu R cube omega L upon H. Okay, and if you want to calculate the power loss, so this is very, very important. This is very, very important formula. And if you want to calculate the power loss, that is TF into omega. So this is also important formula. So now there are one question is there. A journal bearing has a shaft diameter. The shaft diameter is given, that is R, that is given 0.02 meter. So diameter, that is 40 mm. So the radius will be 0.02 meter, and the length is 40 mm. So the length, that is 40 mm, that is equal to 0.04 meter. Okay, the shaft is rotating at 20 radian per second. So omega is given, that is 20 radian per second, and viscosity of the lubrication is, that is 20 into 20 millipascal second. So the viscosity mu, that is equal to 20 millipascal second. So that is, it will be equal to 20 into 10 to the power minus 3 Pascal second. Okay, and the clearance is also given, is equal to 0.020 mm. The loss of torque due to the viscosity of lubricant is approximately, so you have to calculate the torque. Okay, you have to calculate the torque. So here we know the formula, that is torque, that is to 2 pi mu R cube omega L upon H. So from here 2 pi and mu is 20 into 10 to the power minus 3 R cube is 0.02 to the power cube into omega. What is the value of omega? That is 20, and L, what is the value of L? That is 0.04, and H, that is 0.020, So if you calculate this value, so this is 0.020 into 10 to the power minus 3. So here, so this is in mm, so 0.020 into 10 to the power minus 3 meter. So 10 to the power minus 3. So the torque will be, and the final value of the torque, that is will be 0.04 Newton into meter. Okay, so this will be our answer. So this type of question are asked in GATE exam. So this is very, very important. Okay, so now we will see the unit of viscosity. So units of viscosity. So we'll discuss the units of viscosity. So we know the formula tau equal to mu into du by dy. So mu, that is equal to tau upon du by dy. Okay, so what is the tau unit? Tau, that is, we know that the tau unit is Newton per meter square, and du by dy, that is meter per second upon meter. Okay, so from here the unit will be Newton second per meter square. So this is very, very important. So unit of viscosity, that is Newton second per meter square. So if you see that in Newton, you can say that is kg meter per second square into second upon meter square. So the unit will be, the unit also will be kg meter second. Okay, and this is the SI unit, and the CGS unit will be dyne second per centimeter square. That will be gram centimeter into second. So this is also known as poish. So this is very, very important. This is the CGS unit. This is the CGS unit, and this is the SI unit. Okay. So there are one relation, that is what is the relation between CGS and SI unit, and one poise, that is equal to what Newton second per meter square. So the CGS unit, that is gram centimeter per second square, gram per centimeter into second. So if you convert this in CGS unit, so in SI unit, that is 10 to the power minus 3 kg by 10 to the power minus 2 meter into second. So that is will be equal to 0.1 kg meter second, that is equal to 0.1 Pascal second. So from here you can say that 0.1 Pascal second, that is equal to 1 poish. So this is very, very important. 1 poish, that is equal to 0.1 Pascal second. Okay, now we will discuss about the units of kinematic viscosity. Units of kinematic viscosity. So the unit of kinematic viscosity, we know that nu, that is equal to mu by rho. So what is the unit of mu? That is, we see that kg meter second by kg per meter cube. So from here you can see that meter square per second. Okay, so this is the SI unit, and centimeter square per second, this is the CGS unit. So this centimeter square per second is known as Stoke. So this is the CGS unit of kinematic viscosity nu. Okay, so this is all about the units viscosity and kinetic viscosity unit, and there are concepts in a linear velocity profile assumption. Okay, thank you.